Hey, howdy, fellas. Here's a greeting from Texas. I am Qisha. I had my PhD degree from University of Texas at San Antonio last year. And our topic today is AlphaDog, no-box camouflage attack via alpha channel oversight. And this paper is co-authored by my advisor, Dr. Chen. It's not opening. This one? Okay, cool. Okay, so let me introduce the background of adversarial attack to you guys a little bit. Traditional black box adversarial attack on computer vision models, such as a gradient-based attack by Goodfellows and image scanning attack by Xiao, they face significant limitations. For example, they require intensive queries, and they have time-consuming iterative process, and they usually are model-specific, which means they lack universality. And because of the subtle perturbation, they usually suffer low attack success rate and low confidence level. To overcome such limitations, we propose AlphaDog, which is the first no-box attack, which means we literally require zero query. And it is universally adapted, which means it is model agnostic. And we can guarantee 100% confidence level and attack success rate. So what is AlphaDog? AlphaDog is an alpha channel attack. It is actually an adversarial attack. But it is the first universally efficient targeted no-box attack. It exploits the often overlooked alpha channel in RGBA images to create the visual disparity between human perception and machine interpretation. It can efficiently deceive both. And yeah, this is our website. Unfortunately, I cannot click it here, but yeah, you can check out the demos. We attack all the popular computer vision models such as ChatGPT, Amazon Recognition, the Google Cloud API. Yeah, they all suffer from our attack. And in AlphaDog attack, we have two targeted images. For example, the left one is what human eye is gonna see. For example, it's President Biden, right? But if you send this attack image to an AI model, it will recognize as President Obama with 100% confidence level. And in the demo, we also make human eye to recognize as a cat, but AI model recognize as a dog. And here, human eye recognize as a healthy hand X-ray picture, but the AI model recognize it as a broken hand X-ray picture. Here, yeah, this is for like autonomous driving. The human eye recognized as 20 miles per hour on the speed limit sign, right? But AI model recognized 75 miles per hour. Okay, yeah, that was so much about demos. Let's talk about the AlphaDog Foundation. First, I have to introduce the visual cryptography. So what is visual cryptography? When the attacker carefully design two seemingly nonsense image and overlap it, then they can generate a new picture with new image. This is visual cryptography, and AlphaDog is inspired by visual cryptography. These two image. I actually want the attack image and the background of the image viewer. When we overlap them, the human eye and the AI model are gonna see totally different pictures. Okay, now let me introduce what is alpha channel and what is RGB channel. So old image format, for example, JPEG, BMP, they have only 3 channels RGB channel. However, modern images like PNG, HIFF, GIF, WebP, they have 4 channels, RGBA. You know, RGB channels are like red, green, blue color channels. But A represents the alpha channel. The alpha channel is actually the transparency channel, and its values are usually from 0, which is fully transparent, to 1, which is fully opaque for each pixel. And we notice that the AI model developers, they don't care about alpha channel. When they try to process an input image, they simply just remove the alpha channel and only process the RGB channel. And that's the root cause of our attack. Okay, then let's talk about the background color of different image viewers. So we use the digital image media, aka image viewers, to view an image, right? For example, we usually view an image on browsers such as Chrome and Safari, or sometimes we open an image locally using, for example, Microsoft Paint or Mac Preview, right? They all have background colors. This example is an example of opening a Lena image using Safari. And you can see that the background color is white. And this table summarizes the popular image viewers' background color. For an image viewer, they usually have two types of display: the thumbnail and the viewers. And we notice that most of them simply use a white background color. Only two outliers, which is Windows Photo and Mac Preview, they use gray color as a background. Then, how exactly AI models treat alpha channel? We just talk about actually most of them just remove our channel, right? So here's our detailed investigation of how they're gonna treat them. We investigate 80 open source models and 20 commercial off-the-shelf models. The 80 open source models are from highly rated GitHub repository. They are popular models, for example, the ULOS, the Faster RCN, and the Alex Late. And they are trained based on the popular data sets, for example, Coco, for example, the ImageNet. And the commercial off-the-shelf models are very popular CV models. For example, the Google Cloud Vision API, the BARD, actually is now renamed as Gemini, right? And Amazon Recognition, and for example, ChatGPT, and Microsoft Azure, Tencent. So as you can see, all the we invest in all the, if not all, most of the popular computer vision models, and we notice that, and we observe such consistency. Most models, they simply removed in input images alpha channel, except there were only two outliers. The Google Bard and Google Cloud Vision API, they add black and white background colors. So this consistency ensures the no-box attack scenario of AlphaDog. So by no box, we mean there's absolutely zero query. The attacker just can assume that the victim AI models just remove the input images alpha channel and attack it. So they will attack most of the commercial off-the-shelf models and the open source models. Okay, so much about the root cause of the AlphaDog attack. Then let's talk about how to create an AlphaDog attack image. So first, let me introduce some annotations. So we use this ATK to represent the attack image. An attack image consists of two parts: the RGB channel, which is IIN, and an alpha channel. We use the uppercase A to represent. And after this attack image is overlaid on a background, you will experience such thing called alpha composition. Simply put, it's going to blend with the background color and generate this IEYE. This II is what our human eye is gonna observe. Okay, so here's an example of how the attacker create an attack image. But bear in mind, the attacker has to pre-select this II and IIN in advance. For example, the attacker is going to select the IIN, which is for AI models, to be the letter Z, and it will choose the targeted image, the letter K, for human eye. Then the attacker is going to combine these two equations and generate this alpha channel matrix. After obtaining this alpha channel matrix, the attacker can simply just concatenate IIN and this alpha channel matrix to generate the attack image. It's very simple, right? So that's how the attacker can generate AlphaDog attack image. And here is the attack process, which means if the attacker fit such an attack image to an AI model, the AI model will simply remove the alpha channel and see the letter Z. However, the human eyes is going to see the blend result, which is a letter K. That creates the disparity between the AI model and human eye. Okay, then another very important thing is how to ensure stealthiness. Simply put, we have to ensure histogram separation between AI. IAI is IIN, right? Because AI model simply remove the alpha channel, so it will just say IIN. So the histogram separation has to be achieved between IAI and II. And here is the mathematical reasoning why that has to why this rule has to be followed. Well, this histogram separation is very important because later in our defense we're going to use this separation of histogram to detect the malicious image. And here's the pseudocode of how attacker can generate an attack image. Well, you can see that the attacker has to pre-select this IAI and IOI, right? And it will use the nested for loop to generate this alpha channel, the alpha matrix. Then it will concatenate them and get the attack image. And we have to note that any image can be pre-selected as target image, right? The attack can select either human, President Biden. It can select the cat and dogs pair. It can select the traffic sign pair. Any image. However, this image pair has to be in the same size. And the format can be PNG, TIFF, HEIF, WebP, and GIF, which means this image format has to support alpha channel. And they can only be grayscale images. And this generation process is very efficient. The computing complexity is only big O of n squared. Okay, so this is AlphaDog evaluation. To evaluate the stealthiness of AlphaDog attack images, we actually generate the 6,500 attack instance, and we invited 20 participants to observe these attack images to see if they can find out this image is malicious. And the result is very promising. Nobody can realize it's not a normal image. So this guarantees the stealthiness of the AlphaDog attack image. And to evaluate the attack success rates on different AI models with different image format, we summarize this table. And we can see that for PNG images, all the AI models can accept that. So which means the PNG should be the best choice for the attacker to select to attack an AI model. The other image format, some of them can fail simply because the AI model doesn't support such image format. And here's a difference. So how do we defend against the AlphaDog attack? So recall that there has to be a histogram separation between the IIN, which is the RGB channel image viewed by AI model, and the II viewed by human eye, right? We can use this feature to determine is this a normal image or it is a malicious image. Because normal image, they don't usually clearly separate to histogram. So by achieving that, we are going to blend the input image with different level of background from 0 to 255. And we're going to check, is any histogram overlap greater than 5%? If it is, then we say there's no attack. Otherwise, we're going to say we detect an AlphaDog attack image. And this is the evaluation result. We actually tested 1,000 AlphaDog attack image pair, which means attack 1,000 malicious image and 1,000 benign image. We select randomly from the internet, and we find out our defense methodology can 100% detect the malicious attack image. Okay, here's the conclusion. We present AlphaDog. AlphaDog is a groundbreaking advancement in adversarial attack by exploring the I/O flow of computer vision models. The I/O flow is that they usually just ignore alpha channel. And we have such advantages. For example, it's the no-box attack, which means zero query is required, and it's model agnostic, which means it's universally adapted, and it can be guaranteed generated efficiently with the computational complexity of big O of n square, right? And it has a guarantees 100% confidence level and attack success rate. And the attack scenario can be AlphaDog can be used in data poisoning, evasion attack, content moderations, and it can potentially be used to harm autonomous driving, medical field, and facial recognition. And we also create a data set of 6,500 attack image for researchers to test it. Okay, thank you so much for listening. Yeah, any questions?
Thank you, Dr. Shah, for your great presentation. Any question from the audience?
Hi, I'm Tatsuya Mori from Waseda University. Thanks for the very interesting talk. And the application for your research, you mentioned that it can be applied to autonomous driving. So it implies that it can be kind of online, real-time processing to inject the alpha channel attack. So how can you make this attack in a real-time manner?
Yeah, very good question. So as you can see, our attack scenario is data poisoning and content moderation. So in that case, autonomous driving, they are the AI model is based on training, right? They have training. They have a lot of, like, for example, traffic sign image to train it, right? By doing this, we can do the data poisoning. We can moderate the content of the traffic sign. For example, 75 to 20 miles per hour. That's in that way we can affect autonomous driving. Yeah.
That makes sense. Thank you.
Hi, thank you for the great work. And I have one question. So
yeah, go ahead.
Can we apply your work to the video domain, such as like MP4 video format?
Yeah, that's a very, very good question. Yeah, so for the video domain, currently I haven't found any video format that includes the transparency channel. However, it can be used in the game domain. I realized that there's a software rendering a software called the OpenGL, right? They have transparency channel. So yeah, it can affect the simulation domain.
Thank you, and let's thank our presenter.